Now in section 5.2, we're looking at volumes of revolution around the y-axis, and that would look something like this. Here is my y-axis, here's my x-axis, and I've got a curve that does something like this, and I'm going to take this part of the curve and rotate it around the y-axis. So again, apologies for my not excellent drawing, but this is what we're going to get, something that looked like this. In this case, we get this sort of slightly frustum-shaped solid, okay? Now, in this case, all we've done is we've swapped around the role of the x and the y. Okay, if you go back to section 5.1 and look at everything we did there, exactly the same thing's happening, only where we had x's, we had y, now have y's, and where we had y's before, we now have x's. We just reflected this picture, haven't we? So in that case, in the formula, we're going to be able to do the same thing. If we just change the formula around, change all the x's and the y's in the formula, then that volume is going to be given by this formula. We've got to be a little bit careful. The a and the b now have to be y values. So it's the integral from a to b of x squared dy. If the question gives you the x values, if the question gives you these points here, you're going to have to be careful to convert those into y values before you do your integration. Now you might think, okay, that's fine, but sort of why bother doing this as a separate as a separate section? This is hardly any new information. Well, the thing that we've got to be careful about, and I suppose the reason it's worth doing, well, is because if you're given a function, you're normally given it as y in terms of x. So there is an extra sort of warning that you need to rearrange and get x in terms of y if you're going to integrate x with respect to y. So a typical mistake that people will make on an exam would be to take square root of x squared minus 1 and just put it in there, because you think, well, take the function, square it and integrate. But in that case, we wouldn't be integrating y squared, we wouldn't be integrating x squared, we would be integrating y squared, and there's a problem. So we need to rearrange this. Y squared plus 1 equals x, and our volume is pi times the integral of y squared plus 1 all squared with respect to y. Okay? Now, we also need to be sure that we've got the limits right, and in this question, they just tell us, I'm looking at example 2 on page 76 here, they ask us to integrate from y equals 1 to y equals 3. If they're feeling sneaky, as they are on exercise 5b, question 1d, they've given us x equals 5 and x equals 11, so you're going to have to change that into what's the y value for x equals 5, what's the y value for x equals 11, and that will give you your upper and lower limit on your integral. Other than that, we're just going to take this and proceed as usual here. Of course, when we integrate, we're going to have an answer which has just got y's in it, but that's fine because we're going to substitute in the 3, substitute in the 1, so it doesn't matter that there's y's instead of x's. In some questions, we like to kind of finally give our answer in terms of x's instead of y's, and sometimes we have to worry about that if we're being asked for functions, but here we're not being asked for a function, we're being asked for a final answer of a volume which is not going to have x's or y's, it's just going to be a number once those limits have been substituted in. So once we get to here, it's just an integration question, and hopefully not too tricky an integration question as well. Okay, that's 5.2.